All right, hey all you cool cats and kids, here for part 5 of the Homework 10 series. We're going to be determining the strongest type of intermolecular force for these 6 compounds down below. So our game plan is that we're going to draw the Lewis structures out, and we'll determine which intermolecular force is strongest for each of those compounds. All right, so we're going to skip to the good part, get straight into the Lewis structures. We have them all shown out right here. Looking straight at CO2, we can see that we have this equivalent bonded around our central atom nonpolar molecule that's going to make CO2 only have London dispersion forces. We then have that diatomic hydrogen bond. This is going to be also a nonpolar molecule, so it's only going to exhibit London dispersion force. Then we have this thick organic molecule over here. So we've got some hydrocarbons. Then we have a carboxylic acid group over here. We can see this OH, and this is going to allow us to hydrogen bond. We have hydrogen connected to an electronegative atom. Then this electronegative element also has lone pairs. So if we had 2 of these particles, they were near each other, they'd be able to hydrogen bond with one another. So this is going to be hydrogen bonding for our strongest IMF. And we have NH3. So we talked about NH3 previously in this video series. I forgot to draw it if you couldn't tell, hence the subbed in, the only good looking Lewis structure in my opinion. But we have this NH3 here, and we can see that it's also going to be a polar compound based on the Lewis structure. We're polar, and we also have these nitrogen to hydrogen bonds, and we have some lone pairs on this central nitrogen. It's going to allow NH3 to hydrogen bond. So this is going to be hydrogen bonding for our strongest IMF. Then we have BRF3. So BRF3, you should have a central bromine with 3 fluorines attached to it. And you're also going to want to have 2 lone pairs around that central atom. So this is going to be a T-shaped molecule, T like Mr. T. And this is going to be a polar compound as well, because we have unequal distribution of electrons around this bromine. That's going to lead us to being a dipole-dipole intermolecular force as the strongest one for bromine trifluoride. We just don't have any hydrogens to say that we are hydrogen bonding, so we're just dipole-dipole here. Last up, we have xenon tetrafluoride. So if you draw out this Lewis structure, we're going to get 4 xenon to fluorine bonds and then 2 lone pairs, one on top and bottom. If we think about this shape in VSEPR, what that's going to look like is just a square. It's going to be square planar. Sorry, I was trying to think of the term for it. But yeah, this will be a square planar shape. We'll have lone pairs on top and bottom. The lone pairs on top and bottom will cancel one another out in terms of their dipole moments. And then we have these 4 fluorines all 90 degrees apart, pulling equally away from each other. So those dipole moments will cancel as well. This is going to be a nonpolar compound overall. And XeF4 is only going to display London dispersion force because it's nonpolar. All right, that's the end of video 5.